Okay, so if we take a look at this question, we're looking at having a decrease in the acidity. And so we want to have the strongest acid listed first, the weakest acid listed last. Hopefully pretty quickly you could narrow this down to just two options, because we know that HCl, or hydrochloric acid, is a strong acid. And so it's going to have to either be C or D, right? So the real question becomes, how do we order the other things? And so let's look at our trends. So if we're trying to compare these, there's two different ways to look at it. We can look left to right, and we can look up and down. And so we'll start with up and down. Let's compare oxygen to sulfur. So oxygen is above sulfur on the periodic table. And what that tells us then is that sulfur is larger than oxygen, right? As we go down the periodic table, atoms get larger. So sulfur is a bigger atom than oxygen is. Because it is bigger, and again, because up and down on the periodic table, the dominant factor is that size of the atom that the hydrogen is bonded to, it means that the hydrogen-sulfur bond is going to be a weaker bond than the hydrogen-oxygen bond. They have similar polarity. Oxygen and sulfur are not super different in terms of their electronegativity. And so the size of the atom is going to be the thing that ends up mattering for us. And so the HS bond is weaker, which means that HS is a stronger acid, or H2S, I should say, is a stronger acid than water is. They can both donate protons, but H2S is going to more readily donate that proton than water is. We already said that we know that chlorine is the strongest acid of this list, but let's think about it from the periodic table perspective and how we can make that prediction from understanding fundamentally what it means to be a strong acid. So sulfur is to the left of chlorine on the periodic table. And so what that tells us then is that chlorine is more electronegative than sulfur is. They're similar in size, they're a little different, but they're pretty similar in terms of their size. But chlorine is more electronegative, which ends up meaning that we have a more polar bond for HCl than we have for the HS bond. A more polar bond means it's going to be easier to donate that proton as a proton, and it will come off as an H plus instead of being able to break that bond as a hydrogen atom where it has both the proton and the electron. And so that more polar bond means it's going to be stronger. So HCl is going to be stronger than H2S, and we already know H2S is stronger than water, and that gives us our rank ordering here, where we're going from strongest acid down to our weakest acid in this case, which is water.